Yeah, once again, morning all. Good morning.
Good morning, sir.
Good morning, sir.
Good morning, sir.
Good morning, sir.
Yeah, in continuation of last class, here I think the last class. Is this screen is visible? Is this screen is visible?
Yes, sir.
Yes, sir.
Yeah. So in last class we discussed about levels of abstraction. DBMS levels of abstraction. Can anyone tell what are the levels of abstraction in DBMS? Any one of you, please reply. What are the levels of abstractions in DBMS? Hello. How many levels are there and what are the levels of abstractions?
There are three, sir. Three levels.
Yeah, three levels. Abhilash, I texted. What are those? Tell me.
Physical level,
Logical,
logical,
extension.
view level.
Yeah, Rohit Chaudhary. Good. Abhilash, Sai Kumar, people are texting the things. But instead of texting, most possible, please try to respond with unmuting the video. Right? That is good for me. Okay, right. Okay, good. There are three levels. Means when we are going to design a database, any kind of database, whatever I given 16 databases examples for your diagram. Then whatever the database, not only 16, any database, if we are going try to implement any database, then that database must follow these three levels. If your database is following these three levels of abstraction, your database is success for all the categories. So that we must follow these three levels. That is physical level or physical abstraction level or physical view also. View. Sometimes people will ask how many levels of views are there in the video. View and the level they are there. And the next one is the conceptual level, also called as logical level. The final one is the external level. That is, end user they can view the data whatever they want. So this is the three levels of abstractions are there for that DBMS for any database. So that we must follow these three levels for designing of any database. Now today's topic is data models. They're very important thing. So from this, one of the model is ER model. Already we are doing that ER model. We are working on that. Yes or no? Yes or no? 16 databases, some of the entities, relations, attributes we are identified. Yes or no? Hello.
Yes, sir.
Have you identified entities? Yeah. Yeah. We already know some information. Yeah, like that. We have not only ER model, we have so many 11 types of data models we have for the database management system. So that we are going to learn what are the models are available and what is the importance of that model and every model what are the features are there and how to do that. All these things we are going to learn today. Out of that, in your syllabus, they are given ER model and relational model. ER model is the first experiment, and relational model is the second experiment. That's why here, out of 11, only two is there. But introduction in first unit, they are given data model. So we have to learn those models one by one. Now this screen is visible. Is this screen is
Yes,
visible?
sir.
Yes, sir.
Yeah. We know already I told you why data models are required. Already I told you the data models are very useful for representation of the data in a graphical view. If the representation is a graphical mode, then the information is going to understand everyone initially. So once that model is perfect, then implementation of database is very, very easy. That is why the understanding is more easy with the help of these data models. So that here, please understand these data models and design the database. Before designing the database, we must design a data model. That is the main point. So why? It is a graphical representation so that everyone can understand very easily, even end users also. Clear? Hello?
Yes, sir.
Yeah. Here in a database management system, we have 11, basically 11 types of data models. Okay, we will discuss one by one. The first one is the flat data model. So this flat data model is nothing but it is going to store the data in a traditional way, nothing but directly we are going to store. So whatever the information we are having, we are going to store traditionally. So that is an old model, which is not a scientific one because whatever the data is there, we are going to do. For example, any data you want to maintain, we are going to prepare one table and we are entering the data. So that is the old one and the traditional one. Flat data model is the first and foremost introduced model, and it's all the data you kept in the same plane. Same. There is no any constraint. There is no any security. There is no any condition. So directly, whatever the data we have to store. So that is what the flat data model. Clear? So like this. Roll number, name, course. But there is no uniqueness and there is no any constraint, there is no any other things. Simple information. Generally, whatever the information we are going to store, that information we have to enter in a tabular fashion. That is a flat data model. Clear about this? Don't
Yes, sir.
confuse. Yeah, please understand the terminology. Okay, clear?
Yes, sir.
Yes, sir.
Yeah. Now, next model is the entity relational data model. Here we are aware of this model because already we are working on this. This entity relation model is the second half. First unit, second half completely is a ER model. And even we have one experiment in the laboratory. As per our syllabus, we are going to design the data with help of ER model only. So that already we are aware. The entity relationship, the very important thing is two things, especially that is entity and their attributes and relationships among entities. So these two we have to identify initially. These are the two major things. So these two things only we did in the last lab. So I am going to verify, I am going to check in the Saturday coming laboratory. All your identified entities and their attributes along with the relationships among the entities were identified or not, I will verify because I have given this task for the next laboratory. Correct? Yes or no? Hello?
Yes, sir.
Yeah, how many of you identified entities and attributes and relationships? All of you identified for 16 databases? All of you identified.
Yes, sir.
Yeah, please. If still anyone is not identified, entities and their attributes and the relationships among entities, please try to identify. If it is wrong or right immaterial, don't copy from others. You write your entities and its attributes and relationships. Don't worry about it. Anything is there, I will correct it. But you analyze, you think, you identify. Okay? Don't think all the entities must be same from your friend to you. Okay? Sometimes it is different, not a problem. That is your perspective and that is your requirement. So you feel like that, that is right. Already I told you the entity relationship, especially these are, the entity representation is rectangle and relationships is the diamond and attributes are over. You know very well. Then how to connect a student enrolled in course. Yes, student enrolled in course. Here, student is having some of the attributes, including the property. That is student name, student address, student major is about a department. Major means don't confuse. It is a department. And the student assignment, I think all ticket number. Like that, student is having more attributes, but here I have taken only four attributes. And enrolled in course. Here that course is a entity. Course also having some attributes. That is a section as well as teacher. Or maybe the course ID you can add course idea also, idea of the course or something, whatever the attributes you want to add, you can add. Now you know how to define the AR model, data model. Understand this. So one more example. Teacher works for department. You know, teacher is having some attributes, department also having some attributes. So this is the relationship. So how to represent AR model, you can understand basic model. Clear everyone?
Yes, sir.
Yes, sir.
Yeah, this is ER model. The data we are going to represent in the graphical way because of ER model. So in this model, we have some features. What are the features? It is a graphical representation for better understanding. Yes or no? So, because we can understand very easily. The teacher, what are the proper? Teacher works for a department very easily. Anyone they can understand. Even non-technical people also, they can read and they can understand. Okay, yes, teacher works for department. Teacher is having teacher name, teacher ID, mobile number, age, salary, department number. Everyone they can understand. So that's why this is a graphical representation for a better understanding. Easily, everyone they can understand. Maybe the stakeholders, some of the clients, they can understand very easily. What are the parameters we are using? How the model is going to construct? Clear? The first feature is clear for ER diagram. Hello. I told you I need response.
Yes, sir.
Hello. Yeah. Next. Here, ER diagram is a visual tool. Here, ER diagram implementation, we have one tool to representation of this model. There is so many tools are available in online. But as per our academics, we have to use only the handwritten things for this ER diagram. But the models, the tools are available in the market so that easily we can design the ER model for any case. Okay, we are academically we are going to identify very small data sets. That's why it is enough to draw in paper. But coming to the reality, so many attributes are entities are there, and so many attributes are there, so many relationships among them. So that maybe the drawing is not possible, so that they can use tools and the database design. Yeah, so this is more helpful for the database design because whatever the ER model we are going to construct, same thing you can convert into the relation model because whatever the things we are using ER model, same thing we have to just conversion. Nothing is there. No need to think again. If you are going to design a ER model perfect manner, but then relational, whenever you are going to construct a relational model, no need to think anything. Directly you convert as it is to the relation model. That is why you please think about the database design is very easy when you are going to design a ER model perfectly. Clear? The features of ER model is clear, everyone?
Yes, sir.
Sir.
Have you clear?
Yes, sir.
And is running out of finish all models. Yeah. Now next one is the advantages. Yes, here it is having more advantages. Basically, here it is a simple. The ER model designing is very simple. Yes or no? Everyone they can easily design the model. If you know the how to represent that entity or attribute and relationship, then the representation is very easy. Simple. We can design the model very simple. And effective communication. Yes, it is more effective communication. No need to write the statement directly. We can understand. Teacher works for department. Here, very simple. We can write and we can understand, and even communication means connecting also very simple. Teacher works for department. Teacher will work for department. Anything he will work. So that's why here the communication, the connection is very easy and understand. Even everyone they can understand very easily. So that's why here this is the advantage. The last one is the easy conversion to any model. Yes, from ER model you can convert to any model very easily. Already I told you. If you know the ER model is good, here the relation model easily you can convert it. Easy. Any model you want to convert from ER model, it is very easy. So that's why these are the three advantages: simple, effective communication, and easy conversion to any model. Clear? Advantages are clear, everyone?
Yes, sir.
Yes, sir.
Here, you can model is a second experiment, then you advantage because we are not converted still. That's why. Okay, you can get the clarity with the experimental. Don't worry about that. Clear, clear. Hello. Are you clear about these advantages?
Yes, sir.
Yeah. Coming to the disadvantages. Here, no industry standard for notation. Exactly. So this is one standard from the industry because from some notations, industry is not given any standard because some people will use some different notations, other people will use different notations because there is no standard procedure. So that I will draw my ER diagram, then I will show the same ER diagram to some other people. They don't have another. They have the knowledge of another notation. So that some confusion is there. There is no internationally standard procedure. So everyone they can use their own procedure. So that's why this is a major drawback. Yeah, because someone will design and others they can have some different way. For example, I will tell you, you can understand in the next lab Saturday why it is. I will tell you now. For example, teacher works for a department. Yeah, teacher means all. Only one teacher is going to work for department or many teachers are going to work for department. Can you tell anyone? Hello? Hello? Only one teacher is going to work for department or many teachers are going to work for department.
Many teachers.
Hello, many teachers. Here sometimes people will represent for this. There many means n and how many departments? Many teachers will work for different department or single department. Single department. Here people will show like that n to one relationship, many to one relationship. Some guy is outside, some noise is coming. I told you when the class you are going to attend, you must be in the room. Right. Here many to one relationship. Here some people will be represent same mechanism. Here many means double line they will take. Some people will write many. Here one. Some people will write some different notations. This is one, this is made. But like that, there is no industry standard procedure. That's why the person to person notation representation is different. So that here there is no industry standard. So that sometimes there is a problem. Clear? Clear.
Yes, sir.
And hidden information. Yes, the ER model is having some hidden information. Why? Because teacher. Here teacher means here anyone is a teacher. But here only abstract information we are showing here. Teacher works for a department. Which teacher, which work, and which department. So always, whenever you are going to design a year diagram, here the information is hiding. Only the high level data we are showing in your diagram. So this is it is not a big drawback. These two are not a big drawbacks actually, but drawbacks actually. It is simple and we can solve that. Okay. Clear this? Disadvantages, drawbacks of ER diagram. There is no industry standard and hidden information is there. But it is not a big drawback. Clear? ER diagrams are clear, everyone?
Yes, sir.
Hello? Yeah. Next one is the relational data model. Here, relational data model is nothing but it is a tabular representation. Means we are going to represent the data in a two-dimensional data. That means columns and rows and columns. You know, generally we are using column and row representations most of the cases. If the relational data model is nothing but it is a tabular representation. But here in a DBMS, the technical name, it is a relation. Relation is nothing but a table. Relation is a collection of rows and columns. The two-dimensional data we are going to represent. Now, the conversion from ER model to the relation model is very easy. I will show you. Already I told you the conversion is very easy from ER model to any model. Here now I will show you first experiment to third experiment, how it will in the laboratory. Same way, we have to convert relation model from the ER model. For example, teacher and department, two entities are there. The teacher is the entity, you can take it as a teacher is a relation. Now, attributes are the column name, simple. Teacher name, one column, teacher ID, another column, mobile number, one more column, salary, age. Now, this is the relation model. Simple. That means for every entity, we are going to convert as a relation. Every entity attribute is a column name of that particular relation. So this is what exactly the conversion from ER model to the relation model. That's why second experiment is very easy in your lab. If you are going to design ER model, first experiment very clearly, the second experiment is very easy. Now understand the relation model, everyone?
Yes, sir.
Understood this? Yeah. Now, once the relation is there, high level data, you know already this is a high level data. Already I told you. Also called as abstract level, also called as metadata. Already I told you many times. Now, this is called as low level data or instance, I told you. Because after some time, one record is going to insert, or after some time, the record is going to. At that time, what is the data? So the data is low level only. That's why this is called as instance. Already we discussed all these things. Clear this? How to convert ER model to relational model? Everyone is clear?
Yes, sir.
Yes, sir.
Even second experiment also done. Yeah. Yeah. Now coming to the features of this model, the tuples. You know, the first feature is the tuple. Tuple is nothing but a records. Here, every record is a tuple. Means we have the information. Means here, what is the employee ID? What is the employee name? John is the employee. His ID is there. His job role is there. Salary is there. Mobile number is there. Here, every information is clearly in one tuple. Tuple is nothing but a row. O is called as tuple in a relational model. The total information, if you identify or extract. So that is the feature of the relation model. The next one is input or field. You know already, nothing but it is a column. In order to know how many employees are there, based on the column, I can how many employees are there. If I want to know the employee IDs of the organization, then only I can access this employee name, the mobile number. Directly I can then extract. So that's a particular data in a relation. That is very easy. Clear? Understand the features of relation model now? Everyone is understood? Hello?
Yes, sir.
Yes, sir.
Hello.
Yes, sir.
Yeah. Coming to the advantages. Here it is very, yeah, tell me. Coming to the advantages, it is very, yes or no? Very simple or not? Let's see. You can use very simple, you can implement also very simple. Scalable is very much scalable. Here easily we can add rows and remove the add one more data. Yes, it is scalable. You can add it. If you want to delete something, you delete. Simple. That's why it is a very much scalable. And the third one, independent. Yes, it is having structural independence. Tuple is its independence. Want to know the location of Adam, then if I know the employee ID, then I can access all the data. This data can be depending on or later data. Is having independence. The data completely from the relation based on the particular tuple. Advantages: simple, simple, and structural independence. Clear? Clear? No. All of it getting any response here.
Yes,
Advantages
sir.
of relational model. So this my voice is audible.
Yes, sir.
But advantage of relational model. Now coming to the disadvantage. So two disadvantages are there, but it is also not a big problem. Generally, overhead. So why hardware overhead? When we are going to design a relation model, the data is huge. There is a chance because VR model there is only high level data. There is no low level data. But coming to the relational model, along with high level data, more low level. That's why the data is huge. Then where maybe it is there is already it is not a problem now using high end systems. Now next one is a bad design. The bad every why it is not a problem, but the design means for every entity we need to design a relation. But all the relations we have to connect. We have to connect with the one diagram. A diagram very easy. Everything we can show you. Into a relation, every entity we need to design a relation, and in that are the data. So that sometimes confusion. These are the table and it is connecting and the column. Here very easy. Teacher works for department. So this connection is there. But here also how to make the connection from here to another relation. So these all these things sometimes it will be complex, but finally, comparatively remaining models, the relation model is the best model. We are to use the relation model so that our database management system also called as sometimes relational database management system (RDBMS), because always this DBMS is based on relations. So that another name is relational database management system. Clear? These are not a big disadvantages, but it is there, but slightly we can manage it. Clear about this relational data model now, everyone? Have you clear this relational data models?
Yes, sir.
Hello. Today, very less response. I am not getting proper response from you. I am asking many times, even people are not responding. I don't know. Especially today, no girl is responding. All are sleeping or all are attending or not, I don't know. Okay. Next model is the network data model. Here it is very simple data model. Here we have to connect one entity to another entity. Here one data to another data. Simple, directly. So that's why here it is connected all the entities. So for example, store is connected to the customer, connected to the order. Store manager order. Store the salesman and items, salesman and order. Here it is connected, connecting. Only that information is transferring, and there is no thing, but it is a graphical representation. But there is no exact information we cannot get, but we are not using. Only some of the cases we are going to use network data model. For example, when we are going to visit any shopping mall or any other big building, we have to show one representation. If you go this and it is the something is there. If you even go our college also, every block there is a one chart is there. If you are identified or not, I don't know. In the chart, they will very clearly they will mention your left side. You move to left side, there is a lab. Move to right side, there is a washroom. Like this is nothing but a network data model. It's information we are to give, but it is not a good for database design. But we can show the data in the form of network. So that is what exactly the network data model. Clear, everyone?
No, sir.
Yes.
It is having several paths, already I told you. So not clear? Okay, I will tell you again. The network data model is nothing but it is going to connecting. The data is connecting to different paths. For example, when you are going to enter our college, go to the A block. When you are entering A block, there is one chart. It is going to represent that. If you want to go to second floor, you go to up. If you want to go to the washroom, go to right. If you want to go to the lab, go to left. If you want to go to the director chamber, go to the straight. Like that, every floor we have one diagram. Means we are showing the data in the form of connection, networking, connecting. For every way, we have some connectivity. So like that, if you visit any DMart or any shopping mall, there is a one diagram is there. The diagram is going to show the kids wear is in this floor, ladies is in this floor, gents is this floor. Like that, they will mention very clearly in a graphical way. Means it is going to all entities. What a data is connected in different parts to different entities. So only we cannot get any outcome from, we cannot get any storage of that, but it is going to manage the things and manage the situation, identification, and even we have many paths from one entity to another entities. For example, here store and connected to customer, store connected to manager, store even connected to salesman, and customer is connected to order, manager also connected to orders, salesman also connected to orders, and salesman also connected to item. Like that, one graphical representation we have to use. For example, one more example also there for this. College is having CS department and like connected. Not only CS department, we can add more also. Okay, other departments. We can add here. The college is connected all these departments, even though along with the library and the canteen and sports room and everything you can connect it. And all are connected again to students. Yes or no?
Yes, sir.
Network means it is a connecting all the entities. Just you have to show the representation of data, how it is connected. So this is what exactly the network data model. Clear?
Yes,
Clear?
sir. Clear.
Yeah. Features of a network model. Here, what are the features? They are very simple. This model is not good for implementation of database, but it is there. That is what I am telling. So only some of the cases we have to use, but not for the database design. The features are ability to merge more relationships. Exactly. Here we have to provide merge all the relationships. College to CS department. We are merging all the relations directly with one link, one connection. So that is what means very simple, in a concise way we can represent the information. The college is connected to CS department. Yeah, actually, so many things are. College is assigned to MBA work to college CS department. College is assigning maintaining of the institution to CS department. College is assigning for conducting of the CIT classes to CS. Yeah, like that, so many relationships are there from college to CS department. But using this network model, you can merge all the relationships with only one connection, one network. So that is what ability to merge more relationships. Are you clear? Are you clear?
Yes, sir.
Yes, sir.
Hello? Yeah. Next feature is the many paths. Many paths is multiple paths. So we can already I told you just now. So multiple paths. We can reach to orders from store to customer to order, store to manager to order, store to salesman to order. There are many paths we have for one particular entity. So that is why we can take data from any direction so that we can get some more information, some more clarity, accuracy of information. Next one is the circular linked list. Here we have to use the circular linked list mechanism because already I told you it is a network model. So we have to move from like this. College, CS department, students, library, college. This we can use circular linked list data structure and we can implement the network model here everywhere. So the movement is like this. So that's why The circular linked list mechanism is going to help data structure, help to design the network model. Clear the features. All of you clear these features of network model.
Yes, sir.
Hello.
Yes, sir.
Now coming to the advantages. So what are the advantages? So the data can be accessed faster. Exactly, you can access very fast because there is no any confusion. Directly, college is connected to sales department, students, and library. So directly, the data is we can access very fastly, very quickly, without any verification. That's why very easy. And as there is a parent-child relationship, exactly. The parent always everywhere the parent-child relationship is there. So every parent is having multiple child, but every child is having only one parent. The CSE department is having only one parent. Sometimes student is having multiple parents. Yeah, like that, we have there is no chance of only single parent and single child. We can have anyway. So that is what very easy we can understand. Means any change if we are going to in the students, automatically it is going to affect it to the department. How? Here one student is detained, then it is going to affect it to department. It is going to affect it to college. Yes or no? Even it is affected to library also. Yes or no?
Yes,
Yeah.
sir.
Yeah, like that. Means any changes done in the college, it is going to affect it to department and student also. Means it is vice versa process. Yes, that is a disadvantage. As more and more relationships need to be handled, system might get complex. Exactly. The more and more relationships you have to maintain. The more and more relationships. The college to sales department, more and more relations we have to manage it. Sometimes it is a complex problem. The more works we have to assign to sales department, maybe it is a complex problem. Okay, it is sometimes it is not possible. That is one disadvantage. And any change, like already I told you, any change in the student, maybe the like update, delete, add anything, it is affected to its parent node. If any change is done in the college, it is affected to department as well as students also. So these are the two unnecessarily. Something is going to happen, automatically it is affected to students also. So that is the problems will be happen because of this network model. You know, in the network model, one point that you know our internet connectivity is a network model. In middle, one server is down. So next coming nodes cannot be work. Next connected systems cannot work. Yes or no? Yes or no?
Yes, sir.
Yeah, that is the network model is that is the problem. So in middle, something is going to happen. College is good, students are good, but CSC department is not good. So what happened ultimately through college CSC department only students can run. Now what happens? Students cannot get clear information. So that is the big problem. So that's why here this network problem, network data model is when we are going to use. So anything is going to happen in the low level or high level, it is lifted to next level. So this is the problem, this is the disadvantage. Clear? Everyone is clear this? Network data model is clear, everyone?
Yes, sir.
Features, advantages and disadvantages. Now coming to the next model, record-based data model. So this record-based data model is very, very simple. Just the information is going to recorded in the database. Overall structure, you have to store many records. Simple data is going to stored in the records. But every record has a fixed fields and the length of the field must be a fixed. Means, for example, if I take student information, student hall ticket number. Here, yes, student hall ticket number is a fixed length. Yes or no? The field is fixed and the length also fixed. That is okay. We can manage it as a record based. Yes or no? Hello. Every
Yes,
student hall
sir.
ticket number is same length, right?
Yes, sir.
But if I take student name, all student names are same length.
No.
It is not possible for the record-based data model. If we use student department, all the student department lengths are same or not? Same or not? all students department length is same or not?
Yes,
You
sir.
know? Yes. Mobile numbers are length also same. Like that, here whatever the record-based data model we are using, same like relational model only, but the thing is the attribute length, the field length must be same. It is a fixed one. Here all ticket number is 10 digits. Here every student all ticket number must be 10 digits. Your department is 10 digits, the department is must be 10 digits for all the data. So that is what exactly the record based data means. The structure is fixed. We cannot change anything. Clear now? This is also not a good model, but it is there. Some cases we have to use. All of you clear this?
Yes, sir.
Yeah. Now coming to the hierarchical model. It is also very important model. You know already tree data structure, right? Tree data structure is a hierarchical data model. Yes or no? Tree data structure is hierarchical data model or not?
Yes, sir, it is.
Yeah, same. Same. Here also we have to use the data in a hierarchical manner. So some of the data we can use in a hierarchical way, like a tree data structure. As per the tree data structure, you know, every parent node is having more child nodes, but every child node is having only one parent node. This is what exactly we know in the tree data structure. Same way, hierarchical data structure means tree data structure is depending based on hierarchical data structure only. We know that. Same features are there. Here also, we can use, for example, here shoes is a parent or the root node. Okay, maybe here again it is a categorized two ways. Women shoes are men shoes, and again women shoes is categorized again high heels are something I don't know this name also. There are men shoes, sports and sneakers. Like that, here we can categorize means classification. It will be done. For example, already I told you many times, the college if you take as a root node and departments is a it's college and it's child nodes, and from here in charges means class teachers. From here students. Like that, your data is going to transfer from bottom to top to bottom. This is the hierarchical model. Even animals also, if you are going to classify using this hierarchical model, your animal, maybe the pet or maybe the wild animal, like that we can categorize. Here, this hierarchical model also, most of the cases it is helpful, but not a good way of designing of the database. But it is also good for representation of data and maintaining the data. Is it clear, everyone? Clear?
Yes, sir.
Already you people are aware of this. Yeah. Now, the features of hierarchical model. There are one-to-many relationships. Yes, exactly. One-to-many relationships. How? The root node, multiple child nodes. Everywhere, parent node, multiple child. That's why it is a one-to-many relationship. It is possible. Clear? Clear?
Yes, sir.
Hello? Now, parent-child relationship. Exactly. Parent-child relationship meaning is what? There any change, any information or any change is going to done from here, automatically it is going to reflect. That is what a parent-child. Any change you want to do here, it is reflected to its child. That's what parent-child relationship also there. Now, deletion problem. Exactly. The deletion problem, you know very well. When you want to delete this particular node, this particular data, then we have to follow some rules and regulations. Already we know the tree. If it is a binary tree, we know how to delete. If it is having a leaf node, we can delete it directly. If it is having single child, again we have to connect it to its parent child. If it is having two child, then we have to do. That is a binary search tree. It is possible. But normal tree, if you want to delete directly, is a big problem. That is what the hierarchical model is having the problem. Clear? Hello? All of you clear?
Yes, sir.
Yeah. Next one is the pointers. Yes, we have to use the pointers to connect. Already we know that when we are going to implement in a data structure of tree, we know if we want to connect the shoes to left side, we need one pointer to connect the left side, and we need one more pointer to connect the right side. We have to use pointers to connect into its child. So that's why pointers also go to white out. These are the four features. That is one-to-many relationship. Parent. It is very simple and fast. Exactly. It is very simple. So any model we can easily analyze and easily understand and easily we can implement. Any change in the parent node is automatically. Yeah, sorry for the inconvenience. Just my side internet is lost. Is it audible?
Yes, sir.
Is it
Yes, sir.
audible?
Yes, sir.
Yeah. Now everyone is clear about the advantages of hierarchical model. All of you clear about this advantage of hierarchical model. It is very
Yes, sir.
simple. Any change you can do in the parent node, automatically it is repeated to the child. Clear? Hello.
Yes, sir.
Yes,
Yeah.
sir.
Now coming to the disadvantages. The disadvantage is it is not for the complex relations because when you have to use a complex relations, the multiple connections, the more relations we need. This hierarchical model is not possible. That is one disadvantage. And as it does not support more than one parent of child, yes, exactly. So sometimes one child node is having more than one parent. If it is like that, it is not possible. Hierarchical model is not possible for if one data is extracted from multiple data. But we know the real world, we are going to extract data from multiple parent nodes. That's why it is not suitable. And the third one is if a parent node is deleted, then the child node is automatically deleted. Already I told you. When you have to delete this, automatically the dog cat also going to delete because there is no good mechanism for deletion of hierarchical model. Clear? Disadvantages are clear, everyone. Hierarchical model disadvantages are clear.
Yes, sir.
Hello. Yeah. Now, quickly, because time is running, I have to finish four more models, very simple models. This is one more important object-oriented data model. Then already I told you the ER models, the extension is the object-oriented data model. Nothing is there in the object-oriented data model, same like ER model, but the representation is different. That is what exactly. You know the employee and department. Employee works in the department, you know that ER model, but instead of representation of in a rectangle, we have to take names here. Methods are nothing but a relationships. So employee get hired to department, employee get change the number to department. So this is the relationship. Method is nothing but a relationship. The same like department also a entity actually, and its attributes are a department and department. Method is change department. So this is what exactly same how to convert ER model to the object model is very easy. Only the representation is going to change. The remaining things are as it is. Clear? That is what I am not giving any advantages and features here. Simple, same thing. The representation is going to change. Already I told you, entity is nothing but a real world existing object. So that here same. Clear about this? All of you clear about this? Hello? Hello?
Yes, sir.
Hello? Is my voice is audible?
Yes, sir.
Is this my voice is audible?
Yes, sir.
Yeah. Object-oriented data model is clear, everyone.
Yes, sir.
Hello? Object-oriented data model is clear.
Yes, sir.
All of you clear this? Yeah. Okay.
Sir.
Now, object-relational model. Here it is the extension of yeah. 8.1 is the object relational model. It is the extension of object-oriented data model. So in this object relational model, there is no any change. It is a combination of both relational and the object-oriented model. It's a combination of already relational model and now object-oriented data model. It is the object relational model is a combination of object relational model. So that is what exactly it is going to fulfill the drawbacks of object-oriented model and relational model, but it is not suitable for implementation of the database, okay, because it is more complex and it is not easy to understand. But some of the cases we can do that. The implementation of object-relational model means it is a combination of object model as well as relational model. Clear? When you want to implement this, we need to proper understanding of the model because we need to design first relational model and we need to design the object model. We have to combine it. Any gap is there, we have to fill it. So that's why it is a combination. It is a hybrid model. You can tell it is hybrid. It's combination of two existing models. Clear? All of it clear?
Yes, sir.
Yes, sir.
Yeah. Next one is the semi-structural model. So this semi-structural model is it's a half design model. So there is no clear structure. It is having only half of the structure, and it is evolved from the relational model. It is going to extract taken the features from the relational model, but there is no complete structure. We cannot differentiate between data and schema also because in a relational model we can differentiate. How we can differentiate? We know already. I told you. If the high level data is a schema. Now this is a schema. Means ID, name, salary, age. This is a schema, high level data, and this is a low level data. That is the instance. We can differentiate in a relational model. We can differentiate data as well as schema. This is a schema. This is a data. We can differentiate. But coming to a semi-structural model, this semi-structural model is there is no structure. It is a only semi. We can take in the features from the relational model, but we cannot differentiate them. It is looking like same data as well as schema. So that's why it is a semi-structural model. It is also not suitable, but web-based data sources. So sometimes we are going to uh, take the data from the website. That sources we can take it as a semi-structural model. Clear? Because data is there, but we don't know that is exactly this is the structure we want. Because any data we can extract. There is no any categorization. The structure, data is called as semi-structural data model. Most of the cases in websites, whatever the data we are going to extract, there is no any structure. Okay, so much of information is there. There is no structure. Exactly what it is. We have to read it and we can use it. Clear this? All of you clear this semi-structural model? Quickly, time is running. Hello?
Yes, sir.
Yes, sir.
Hello? Next one is the associative data model. This is also very important model. Here we have two things. When we have to construct a associative data model, we have two things. One is item, one is links. Item is nothing but a entity, link is nothing but a connection, identifier. Here how it is, I will tell you. For example, here two relational model we have. One is identifier name. This is one relation, and links is another relation. Now we have one link from this table to this table. What is that? Tell me anyone. When you want to access from this table to this table, one data you want to access from here to here. One common attribute is same. What is that? The identifiers is same. Are you clear?
Yes, sir.
Associative model is connected model means, for example, I want to know the by London. Name is London. Here London verb. I want to know the London verb. Okay. What is the identifier London verb? 40. 40 is there. There is no 40. So that we cannot have any verb for London. Here, like that, here the link is identifier. Common attribute is there. There. For example, I added for 40. The source is something, verb is something, target is something like that. Here, when I wanted to know London verb, directly what happened? What is the identifier 40? Now this 40 and this 40 is matches because the identifier is a common attribute in the both the relations, so that I can access the data. So like that, here the linking contains the identifier source, where whatever it is, we have to connect it. So this is what exactly the associative data model means, connected data model. Here, for example, administrative people is maintaining database for fee dues, and academics people is maintaining only the students who are having and who are having backlogs. Now one guy is came from the administrator is calling that one student roll number 40, you send here. Directly I can access from the A section, I will send because that is associativity. If the hall ticket number is same in the administrative office as well as in the academics. So that this is a key attribute to associate two different entities. This is administrative, this is academics. The two different entities, two different databases, but only one key attribute. It is going to associate these two tables. So this is what exactly associative data model. Clear? Clear about this?
Yes, sir.
Hello? All of you clear about this? Yeah, the last one is the context to data model. It is a very complex model. It is a combination of all data model is a context data model. Like this, the network model, relational model, semi-structural model, object-oriented data model, relation, everything we can embed into one model. That is a context data model. It is not possible all the cases, but when you are going to combine all the models, if you did this work, okay, your data model is good. Finally, it is successful of your database. But sometimes, most of the cases, it is not satisfy all the models into one model. That is a context data model. It is very complex. Clear now? All of you clear all these 11 models? All of you clear all these 11 models? All of you clear
Yes,
about
sir.
all these 11 models?
Yes, sir.
Yes, sir.
Hello? Yeah, I will share this PDF to you. Please go through that. Any doubts or any clarifications if you are having,